Your next challenge is entitled Power Ranger. Create a function that takes in n, a, and b, and returns the number of values raised to the nth power that lie in the range a to b inclusive. So let's look at the examples. The first one we have Power Ranger 2, 49, and 65. And we notice that the output is 2 because of the squares between 40, they wrote this wrong, 48, it should be 49 here, that was a typo. So you can think of, okay, 7 squared is 49, 8 squared is 64, 9 squared is 81, which falls outside the range. And if you would have tried 6 squared, it would be 36, and it would be beneath the range, so those miss. But of the squares, those two, you have 2 that fall within the range. And then notice it doesn't have to be squares. We've got cubes here. How many are in between 1 and 27? Well, 1 to the third is 1, so that's in the range. Remember, it's inclusive. 2 cubed is 8, that's within the range. And 3 cubed is 27. If you go above that, you are outside the range. And then we have 10 here between 1 and 5, and the answer is 1. 1 to the 10th is 1. You know, you can multiply 1 by itself however many times you like, you get 1. But yes, certainly that's the only one between 1 and 5. And if you think of a fifth power, right, this one returns 1 because 2 to the fifth is 32. So that would be in range. And then feel free to do the math on the last problem if you like. So, a couple notes. Remember that the range is inclusive, and a less than b will always be true, and that's handy for us. It'd be easy enough to error check that, but I'll assume that it is. So I think we can go over to code. Please pause and have a go at this yourself and resume when you're ready. Okay, let's do... Now we don't want to just start going through all the numbers, right? You don't want to start at 1 and then take it to whatever n power and keep going until you see numbers in the range, right? Because you'd just keep going with numbers. That'd be extremely wasteful, and it's just not very feasible. So let's take a different approach. I'm going to basically grab the nth root of the min and the max to sort of figure out the range of values that we're working in. So let's try, and then think about this too, right? We've done powers in the past, so we can do nth roots. If you remember, a root is sort of the reciprocal of a power. So 5 squared is 25, and if you want to take the nth root, or the square root in the case of 2, you simply take 1 over 2, right? Instead of 2 over 1, you just sort of do the reciprocal to get the square root. So I shouldn't have used 5 as an example because that's not a clean one. But you could think of 16 to the 1/2 power would be 4, right? It's the same as the square root of 16. Anyway, since we've seen math power before, we've used this a couple times, that'll help us. And then so we're gonna let's start with the min, and I'm gonna have to convert this to an integer because we know the math power function returns a double. So I'm just gonna take care of that right now, make sure I cast my result. Min, and then what power do we want to go? Right, it's the reciprocal, so let's go 1 divided by the power, right? That'll give us the root. And I used 1.0 here to make it a floating point type here, so it won't truncate when it does this division here. Consider if the power were 3, for example, I wouldn't want to go 1 divided by 3 as integer. I would lose some precision there. So that's why I did that. We convert it. Okay, I think we're good. And then let's grab our upper bound by doing essentially the same thing on the high side. High round. So we want to do that with max, right? And same thing, 1 over the power. And then to visualize this, let's just write it out. Low root. This will help us visualize. And I'll just say some dummy value now, just so I can run it. Okay, so for this first example, actually to give a better idea of this, I probably should have done it as a double first. Let's do that. Lower, high. Yeah, let's do it this way. This will make it a little more obvious for illustrative purposes. Double. Here, let's run it again. Okay, this is better. So, these are the actual numbers. We know we're working with integers, right? We only count integers for our problem. So on the low side, we're at this 1.98. We know anything less than this number won't fall in the range when you take it to whatever power was passed in. So essentially you have to round this value up, the low one, to the next integer. And it's clear from this one that that would be 2, right? And then you kind of have the same thing on the high end, but you're just going the other way. Anything above this 2.012, etc., will fall outside of the range. So you have to take the floor of this one. You have to round down to the next integer. And that sort of defines your range, right? So the way that you can do this, there are mathematical functions called a floor and a ceiling that do exactly that. Maybe you're familiar with them. Hopefully you are. If not, no big deal. It basically takes you to the next nearest integer. So if you had a ceiling on the number 4.5, it's going to go to 5. If you do it on 4.1, it's going to go to 5. If you do it on 4.00001, it's going to go to 5. Any bit over, it's going to take you to that next integer. That's sort of how it works. And the same but opposite thing is happening on the floor side. So you may guess these functions are in the math class. So math ceiling returns the smallest integral value. Good. And it's going to return it as a double. So again, we'll have to cast there. Yeah, I don't think you need to see the output. Again, I think it's clear from these results, so let's just get to it. And then remember on the high side, we kind of have to do the opposite thing. Math floor, right? We need to lower an integer that falls lower. And then maybe it's clear now from this, when you make these into integers, right? This one would go up to 2, this one would go down to 2, this one would go up to 4, this one would go down to 6. That you can figure out now probably how to return the integer that they're looking for, the count of these powers. You can say high root minus low root, and then add 1 to that for counting purposes. So consider this example, right? We know that the answer is 1, and if you take 2 minus 2, you get 0, and if I add 1, that makes 1. So that checks out. Consider this example, they're expecting 3, right? We're going to round up to 4, we're going to take this one down to 6. 6 minus 4 is 2, plus 1 is going to be 3. You know, you're counting the numbers between 2 and 4 inclusive, so you get this plus 1 thing going on. But yeah, you can look at that with the other examples. This should do what we want it to do. right? These ceiling and floor are gonna take care of getting to the closest integers to those boundaries, and then we can simply count the difference between these integers and add 1 for counting purposes. Let's try this. Good deal, yeah. So you can see it in the output here. 2 and 2, subtract those at 0, you get 1, pass. And we can look at some other examples. Yeah, we did this one on the instructions page. We know it's 2, 49, and 64. We had lower root was 7, higher root is 8, 8 minus 7 is 1, plus 1 is 2. So, yeah, you can look through the other tests if you like. That takes care of it. Not a lot new here. I guess the ceiling and the floor are new. Those are quite handy. And then maybe you just had not considered using power in this way, where you can take roots with it by doing a reciprocal thing. So, other than that, I think we're good. Feel free to share your solutions or hit me up with questions. Otherwise, I will see you in the next challenge. Thanks.